Okay, good morning, everybody. I'm Ollie. Thank you so much for coming down here to Lot 14 and for everybody who's also joining us via Zoom this morning. So thank you so much for taking the time to join the 7th of our Collaboraculture workshops. Also wanted to say a special thanks as well to Wine Australia for helping to make these possible. And we've got Dave Gerner and Paul Smith from Wine Australia here today. So it's great to see you kind of supporting the community and pushing this all forward. So thank you so much. So we've got 5 speakers today, so absolutely tons to pack in. So I'll try and be as quick as possible. And I'm going to do my best with all the speakers to keep them on time. Please, for everybody on Zoom, if you can introduce yourselves via the chat functionality, just so everybody gets to know who's here. And also, if you've got any questions, we're going to save the questions right until the end. But please pop them in chat. We'll get as much answered as we can in the session itself. And anything that we can't answer, we will forward to the respective people and post it on a follow-up email. So we promise we will get through everything as a team. So, just in terms of like where we've come from to be here today. So this is the 7th of our workshops. And in the previous 6 of them, the community has basically come together to agree what are the most important features of vineyards, firstly, to map. So just kind of going from the top down. So it's about, vineyards, and vineyards are made up of a collection of blocks, which is the next box down. And then blocks are actually made up of collections of vine rows. And then vine rows are made up of collections of vines. And then John Bryant, who's been helping us to basically publish and document everything in terms of like the database structure that can be openly out there for everybody. This is the logical data model that we have up on our GitHub page, and he's created a version of this data model as well. So, and you'll see that people are actually starting to now use this data model all around the world, which is fantastic to see. But as a next step, and as the logical next step, obviously, we wanted to move on to how do we actually create accurate and useful maps of vineyards. So in the next couple of workshops, we're going to be really unpicking that. And to start with, we're going to be looking at, how can we survey vineyards so that we can create, accurate, useful, interoperable maps. And it gives me my great pleasure just to introduce Andy, who's going to be our first speaker from Airborne Logic. And he's going to be talking through, how they're surveying vineyards using drones. And then the rest of the speakers will unfold from there. So I'd like to bring up Andy. Thank you so much.
Thanks, Ollie. Excellent to be here, and on a fine, rainy winter's day when we're recharging those vineyards, even better to see that happening out here in Adelaide. So for you guys who are all over the rest of the world, it's deep midwinter in Adelaide, and it's great. Where are we at from a precision mapping perspective? I think it's really interesting to kind of bring some of these concepts and things together that we've been talking about through Collaboraculture for a while now. And I think this little story kind of runs through where we've come from an Airborne Logic perspective about the sorts of things that we do. So I'm going to hopefully try and push that forward a page, but technology's not, oh, there we go. So just a few little things about the things that we do. Precision is really, really important for us because we're essentially going down to the per vine level. So we can't do that unless we've got a level of precision that is going to work across the entire vineyard. So some really important things there for us because we're collecting this data and information at the per couple of centimetre level. We can't afford to be out by 4 or 5 metres. So we've got to think about the different layers of things that we bring together and how we align those things, because we don't want to end up aligning a row in the middle of the interrow and vice versa. So we have to start with precision. We can't do any of what we do down to the per vine level until we've got that level of precision. So it really starts from us going out into the vineyard and recognising the fact that we're collecting this data at lat long level, at the height level, so a couple of centimetres, 5 centimetres in terms of height. All of that becomes really important when you're starting to have a look at a canopy and down to the leaf type level of a vine. So some of the things that we use that to do down to the per vine level is mapping things like NPK, and water stress and so forth down to that per vine level, and then breaking that back out then into usable maps for ingestion back into whatever platform people are using. So whether it's Ollie putting that back into Platform, whether it's somebody that's using a GIS system or whatever system it might be, we've got this issue of interoperability assessed and considered, and the ability to shunt that data across to wherever it needs to go. So I'm going to kind of put Dan on the line here a little bit, and just let him tell a bit of a story.
My name's Dan French. I work with Airborne Logic, and our process is that we fly over the top of vineyards in our drones using our GPS positioning equipment, and we stitch together all those images to produce high definition georeference maps which are accurate to within 2 to 4 centimetres in terms of their placement of all the features on those maps. We then use a grower's naming convention to label all the different block varieties, to define their boundaries, to label their rows, and to label individual vines. Now, the benefits or the uses or the applications that has is that means that everyone referencing those maps, whether that be management, staff, contractors or external parties, are all using the same terminology and the same reference points. So what that means is that or remotely, when you're sending someone to investigate an issue in a vineyard, to replace a missing vine, or if you're defining boundaries for variable rate spray applications, people know exactly where those boundaries or those plants or areas of interest are. It can be directed straight there. It also means that if people are analysing those problems remotely, they can also reference or problem areas.
super quick, and I'm sure we can talk about some of the detail afterwards. So, guys, I don't have my Prezi on screen here. So I'll just keep talking. I should be able to do that. So really what we're trying to say is there's a whole bunch of things that come into play. Things like projections. Anyone that's dealt with precision mapping before, we've got to deal with projections. So if we're bringing in satellite imagery, or whether we're bringing in, that looks promising, if we're bringing in different nomenclatures, all sorts of things, then we need to get that terminology and we need to get that positioning right. And that can be a real challenge when you're bringing in data sources that have been mapped in other projections from somewhere else. So that's our first challenge, is really bringing that nomenclature that we've talked about through Collaboraculture so far, getting all of that right so that it goes into the database correctly initially, and then starting to play around with some of those other challenges, which for instance, for us, because we're in an Esri environment, when we bring in that initial base map, we've got to start aligning against, or aligning, well, which one's more precise? We know we're sort of measuring down to a couple of centimetres, so how are we going to adjust something else that's coming in, like a piece of satellite imagery, for instance? So pretty much what we've been doing is then getting our imagery, which is sort of around that sort of 4 centimetre, 2 centimetre level, trying to align that with some base imagery, and getting us to the point where we can essentially start to overlay those and make sure that we feel like we've got the base accuracy that we need. Then we start to talk about boundaries. So as we've discussed through Collaboraculture, and everybody knows, which boundary? Is that strainer to strainer? Is it corner to corner outside the strainers? Workable area of vineyard? What is it? So working through some of those conventions at the property level to make sure that we're actually mapping the things that that grower particularly wants to identify in their property plan. Then we get to the fun of row. How do we position those rows? How do we get down to the vine spacing then that essentially gives us that accuracy position to measure the things that we then want to measure down at the per vine level? So all of these things tie in. They're super critical. If we get them out of alignment, we then start doing deeper statistical analysis that's just not aligned. And so therefore you start to get variability in your data, and we don't want that variability. So again, this alignment issue, when you're starting to go into this sort of level of resolution, so I think, you know, we're operating around 4 centimetre here. You can see some of that variation in canopy there that we're trying to pick up, and then trying to statistically analyse that through the various other pieces of technology and machine learning and so forth that we use. We've got to be able to get absolute truth around that positioning. So yeah, another challenge there, obviously, particularly at that sort of individual leaf level, which is exactly what we're going down to with the type of other forms of sensor we use, like hyperspectral imagery, for instance. We're down to this per leaf, small size pixel level with deep amounts of data, ridiculous amounts of terabytes of data across a vineyard level to align and make sure that it's giving us these accurate results. So again, you know, that's challenging when we start with a base sat image, for instance, and then trying to align these deep accurate levels. So down to the row lines, and then obviously down to conventions around what are we actually going to call each vine? Is that consistent with what the grower wants? Are they using a particular numbering convention in their vineyard? Have we picked up on that? Have we got these things aligned in the right location down to the per vine level? So that becomes super important, because this is the part where we're starting to have a look at, well, what's this sort of level of data telling us about the vineyard? So in this case, the example here is about showing the missing vines. And then the next level beyond that is, well, what else do we take out of that change over time? Is literally at scale, is down to this type of thing where we're now starting to measure which components. So the red box there is bare wire. The orange box is we're seeing some change in that canopy that perhaps wasn't the same as previously. And the larger box is obviously where we've got a healthier canopy. So how we're capturing that information at that sort of level, and how we're bringing that into some sort of level of meaningfulness that we can now take this out into a larger level and actually help people manage their whole property and get away from, we're obviously not going to go out there and manage each individual vine per se, but we need to put that into a management decision framework that's actually going to work across the vineyard. And that's where we're now pushing these things into things like variable spreading maps for mulching, looking at spray applications, and in fact using this sort of precision type location. We just had a great story from a grower yesterday who said, well, we actually went out and we took some action at the per vine level of retraining on things where we saw there was a problem with canopy, and we reckon we've added about 10 tonnes extra to our vineyard production. That's music to our ears. That's great stories and the sorts of things that we'll be capturing over time as well. So yeah, where does this all end up for us? It's really down to being able to get this stuff down to the per vine level, get it out to a picture of what's going on. Where's the NPK deficiencies, for instance? Where's the water stress? How's that variability showing up in the vineyard? And working with our growers and our clients across the board to improve that uniformity across the vineyard. And these are just a few examples. So the future's pretty exciting about the other layers that we can start to ingest in this and also push it out to other platforms as well. So I reckon I'm probably about out of time, Ollie, and that's it from Airborne Logic for today. Stay tuned.
Thank you very much there, Andy. And just for everybody on Zoom, apologies, Zoom crashed on us halfway through that. We've actually got over 50 people on Zoom, which is the most we've had. So it shut itself for a second. So but it's now back, and hopefully you can hear full audio, and we'll bring up everything full screen from now. So again, it's been fantastic that we've had people from all around the world kind of coming together under the Collaboraculture project. And we've had Matic and Ian over in Europe, and they've stayed up incredibly late to join us tonight. So I just would like to bring Ian Beecher-Jones through. And Ian, if you can share your presentation as well, that will come up full screen. So they've been looking at surveying. Ian comes from a really interesting precision agriculture background in broadacre farming mainly. But he's another vineyard owner in the UK, Jojo's Vineyard, and he's been really looking to bring across all of that experience in precision ag into Viti. So he's going to share what they've been doing in terms of surveying vineyards from the ground and how they're, again, trying to make that as efficient and as scalable as possible. So Ian, over to you.
Brilliant. Thanks, Ollie. Good morning, good evening. It's really good to be here from the UK and joining in this meeting. So I'm just going to share a few minutes with you on what we've been doing at Jojo's with surveying. And we started last year. We started using a Trimble catalyst to be able to survey our small vineyard. Then we also looked at using a Trimble R12i surveying a much higher level surveying tool, which I'll go through in a bit more detail. And we also looked at a DJI Phantom 4 RTK, which Andy has gone through and explained in more detail than certainly I will. And certainly the challenges that he was talking about were very similar to the ones that I faced. The reason that we wanted to look at this was just to be able to establish our digital infrastructure within the vineyard. And just looking at the ways that we went about it, the Trimble Catalyst, looking at some of the pros, it's a very cost-effective tool. I'm not sure if anybody has used it, but to buy it, it costs about $1,000, and then you have various ranges of subscriptions to buy into what you want. It uses there's something called Terraflex software, which is a Trimble software to collect the data, which was really simple and easy to use. The challenges of it, though, however, were it's a lower level quality receiver. Yes, it does survey to RTK, but it takes a little bit of time to be able to for the signals to be able to get to the receiver. And then one of the biggest challenges actually is being able to get it perfectly upright all of the time. And so you have to get the bubble every time you're surveying. You have to get that bubble perfectly within the within the zone to ensure that the point that you're recording is accurate, and you can't place the surveying tool, the staff at the bottom of the post if you've got strainer wires. So there's some element of complexities to that, and it does take some time to survey every single point with a catalyst, mainly due to the trying to get the bubble in the center and getting it perfectly upright. So and at the bottom there we see the spreadsheet of data that comes out, which is pretty standard, and what we're looking for to be able to get the data out as a CSV file and then do something with afterwards. Then looking at the Trimble the R12i, I found this much more user friendly, mainly because of the tilt compensation facility. So you can just press and put the staff at the bottom of the post, and whatever angle you're working at, the receiver will work out the angle and be able to record the point at the bottom of the staff to be able to record that point. So it's much more flexible in its use. However, it does come with quite a high hefty price tag there. You see sort of somewhere around about $38,000. Good collection software as the Catalyst had through the Trimble Access, and it's got good convergence of the GNSS signals from a number of different providers. And you can also use the receiver afterwards for tractor steering and other activities. So it's not just like the Catalyst where you've got just the initial recording points. So those were the two main pieces of hardware that we use to survey the vineyard. And it's a case of, right, you've got all the data points, then sort of so what next? Well, the next part of the task was to be able to take the CSV files from both of the tools and import them into the vineyard, and Matic will talk about the more technical side of vineyard in a second. But what we looked at doing was bringing the CSV file, as you can see there, bring it into the software, and all the points that you see around the vineyard here represent something, either sort of beginning of row, beginning of blocks, end of blocks, mid rows, etc. And we got the boundary around the outside of the vineyard. So these were all points that I collected. Then we drew around the block to be able to create the area, to create the block boundary from there. And then we drew the AB lines. And so these were the two straight lines that represented the rows. Again, these were taken on points that we knew. And then we click the button that says fill row lines, and in the software all the rows are created 2.4 meters apart, which is our row width, and that's done between the two sets of AB lines. Then the most challenging part was then looking at the AB cross posts, being able to identify in the vineyard where these posts are and record them, and that actually was the hardest part. On our vineyard, which is only super small, it wasn't too bad, but if you have undulating ground and sort of vineyards your size, that is a challenge, but I'm sure there's ways around that in which we can sort it out. So we drew the AB cross posts, we drew the XY cross posts in the software, and then we are able to create the cross post grid template, and from there we get the post positions, and then we get the vine positions based on the parameters that we're working on, and all the vines then are populated within that grid. If we look at it a little bit closer, this is a good representation of what the vineyard looks like in real life. If we want to do some finer editing, then we can go into QGIS outside the software to be able to edit and take points out where we've got missing vines, or at the end of rows where posts haven't been put in place after that. And that's something that's really helpful. And then we can save it as a GeoJSON into the main database. Ground truthing is always important as well. So went out and got the tape measure out. This was our reference point, and we can see that we've got 0.42 centimeters of a difference there. We knew that we got sort of fairly flinty ground, and there was a fairly Big piece of flint under that one, but the rest of the points, 2, 3, 4, and 5, were actually pretty accurate. So from the survey points that we'd taken using the software algorithms, it was a pretty good result, and that was sort of fairly happy with that. And so the observations from this little exercise, the more survey points that you take, the better. Pretty logical in that, but it's much easier taking them with the R12i, where we got the tilt compensation, and I'm sure other suppliers do that as well. Where we've got corners, end posts, or posts that aren't in a perfect straight line, we from the outside posts, strainer posts, then we took take readings of those as well. And when we're recording points, if you've got consistency, you've got drop down boxes in any of the software to ensure consistency of data. As we can see in column A, I hadn't got consistency of data input there, so that doesn't help. Whereas if we in column B there, if we've got drop down boxes, it makes data collection much easier after that. As I said, tilt compensation saves a huge amount of time when recording a large number of points around a vineyard. And yeah, if your vineyard's been a lot larger than what we have here, that may help. Ground survey points are recorded at ground level, which I thought was really important to ensure the accuracy of where we are. If vines or posts are leaning, then that's where we have to look at that in a little data a little later on. From when we were doing the drones, when we did the drone survey in comparison, it was a case of what height and whereabouts on the vine or the posts is the data points being recorded. And we also looked at ground control points when using drones and aircraft as reference points. So those were just the few of the points that we collected. So why did we do it? We just wanted to create the digital infrastructure. And once we've got the digital infrastructure of the vineyard, then I, as a grower, can share it with whichever partners I'm looking to do that. I want to work with. And this data that we've collected here is going to be shared with Trimble using the Collaboraculture method. AB line generation for GFX monitors. We've got a Danish spray company that we're looking to work with. We've got Deep Planet as well, that some of you may know, who are just based down the road from us. They came to see the vineyard to understand more about what we're doing, and we're really encouraged by the methodology that we're following through Collaboraculture. Sustainability. The sustainability wine scheme of the UK, of Great Britain, and measuring what we're doing, they're really keen on this model as well, and Bitwise Ag. So once you've got your digital infrastructure, then all of a sudden there's lots more interesting things that we can do. And most of this has really been possible due to the Collaboraculture data model and shareability of what we're doing. So the project that I was just doing in Jojo's last year has really been enhanced with the model and the work that you guys are doing, and it's super positive. So that's just my very quick overview of the experiences that we've had using various different survey tools. Now I'll hand over to Matic now to talk a little bit more in detail about the data modeling.
Yeah. Thank you, Ian, for a very good introduction. So I'll be a bit shorter. You should see my screen now, right? I'll be a bit shorter, mainly speaking about the technical stuff. So my name is Matic Serg. I'm coming from eVineyard. And yeah, as Ian already explained, like eVineyard is basically a vineyard management software. And with Ian, we were working on allowing different features of the software, such as tracking of activities, properties, and so on higher level of precision, on the vine level of precision. And this resulted basically in the need to create a digital infrastructure of the vineyard on the vine level, therefore a map of the vineyard with relevant properties and data attached to different vineyard elements. And how we went after it, so we had a couple of goals. We wanted this generation of digital infrastructure to be quick and simple and as automated as possible after the ground survey is done. We also wanted the technology to be independent from the ground surveying technology used. So yeah, so the points on the ground can be taken using a drone-based analysis, or using a smartphone with maybe a bit less precision, or using a surveying device with a very high level of precision. Of course, depending on the quality of the collected data, the map quality will be as a result. We also wanted ground survey activity to be a simple set of steps, so the person conducting the ground survey knows exactly what to survey around the block. And eventually, if the survey is done in a with a very high level precision measurement device, then the maps should also be on centimeter level of precision. And this resulted in a wizard that is basically enabling fast processing of ground truth data. So the wizard has an algorithm in the background that generates this precise map. I think Ian has shown very well in the previous slides how it looks like, and how the process works for the person trying to generate the map. And then, of course, in the end, we need to store the map along with all the other information. So the thing that we call digital infrastructure in a standard and shareable data structure. And this is where we, early on came across Collaboraculture's data model, adopted it, and at the moment, we're very happy to have done it. So in the process, we have basically learned that we can also generate, besides Collaboraculture's data model points that are defined, some additional areas. As Ian mentioned, for example, for sustainability reasons, things like undervine areas or mid-row areas are interesting. Also post locations and so on. So we have expanded even a little bit on the model after doing this exercise, or basically developing this whole thing. And we also see some additional areas of extension. So this is something that we'll be willing to also push back to Collaboraculture eventually, or maybe align on with somebody else that has discovered maybe similar things. And an interesting thing we learned in the process is defining a good practice for surveying the vineyards on the ground. Maybe some common method, as we will see also from everyone who is doing this. We think there is a lot to put together and come to some conclusions around it eventually. So as a part of this activity, we're also involved in a European project called Atlas. And Atlas is all about interconnecting systems, so interoperability of the systems. And in that aspect, we have also defined some interfaces for digital vineyard infrastructure data exchange. We really worked on the open source technology and standards on that aspect. So we basically developed a very minimal open API specification, which is very lightweight, extremely simple, and easy to implement, and is using basically data exchange for GeoPackage file format for data exchange. And then inside GeoPackage, we have the layers based on the Collaboraculture data structure. So this is one, let's say, upgrade, which eventually we're also interested in pushing it back to Collaboraculture. And that will be my 3 minutes. Thank you.
Thank you so much, Matic, and it's great to see, like the guys in Europe are actually like taking our data model and putting it in like the pan-European system for moving technology forward. So it's great to see it actually getting leveraged. And actually, Matic and Ian are taking forward the start that we've made. So they're adding on to it. So we'll come at the end like about how do we then merge in some of the developments that they're taking, that they're happy to share back with us, so that essentially that data model keeps expanding and expanding. So we build in posts and things like that. So thank you so much to both of you and for staying up for so late. So yeah, awesome collaborators. I just wanted to, again, just very, very quickly, because we're running just a wee touch behind time. Just very quickly, obviously as a team ourselves, we have been getting out there and learning about surveying ourselves. So I just wanted to point out that in the room here we have Rod from Global Technologies Australia. So he's actually come down to our test vineyard and helped us to understand about some of the nuances of ensuring that we get this done accurately. And again, just to pick up some of those things that Ian was talking about where do we take the measurements points from, you know, and we were taking that measurement point from basically the strainer post that you can see. So not the anchor post that's in the ground, but that strainer post. And then basically the work that we've been doing is aligned with what Ian and Matic are doing, and then drawing the vineyard boundary half a row width around the outside of all of our rows. And again, just in our journey, we've been speaking to surveyors, and you know, like we're always looking at how we can leverage other industries. And it's really interesting in spaces like the built environment, there's now a really strong standard for surveying things that are built. And that means, so whenever surveyors are surveying things that are built in Australia, they're basically, like all local authorities, everybody's aligning to this. So that's enabling things like digital twins to suddenly pop up, and there's no questions. You just know that if you're going to survey something, you follow this. And we see a real opportunity to basically not reinvent the wheel, but create an ag spec. So when we survey vineyards, there is a specification out there that we should follow. With that, I am going to pass over to one of our other collaborators since the inception of the project, which is Seb from Concilium Technologies. And he's going to be sharing with us some of the work that they've done to basically look at how you can use the data model and maps when you're going and doing things like ground truthing, where you've got bushfire damage, again, where you're actually physically on the ground truthing, where you've got missing vines. So I'll stop sharing, and Seb, it is over to you.
Hello, everybody. Good morning. I hope you can hear me quite clearly. So yes, I'm Sebastian Wong from Concilium Technology. What I wanted to talk today was about how do you ground truth vineyards for artificial intelligence mapping processes. And I'm representing Green Brain. So what does all this mean? So Concilium Technology, we're essentially an AI company headquartered here in South Australia with 60 employees. Founded by Seth in 2010, and we support customers across a range of industries from defence through mining and resources, energy and agriculture. And what we do is we build pretty cool things using AI technology. One of the things that that was created was essentially Green Brain, and Green Brain has come out of two separate technologies. One was a company called Measurement Engineering Australia, who build and have supported the wine industry for many years with weather stations and IoT devices to measure and monitor soil. And then another was the Geospatial Artificial Intelligence for Agriculture, was essentially a mapping solution, so an AI mapping and satellite information solution. And the purpose of Green Brain is to identify, monitor and measure the world's high-value crops for food and resource security. So some of the things that we've done is generated automated maps of where all the vineyards are in Australia. And to train a machine learning algorithm to operate with satellite imagery, we need ground truth data. That is, we need to teach the AI what is a vineyard and what is not a vineyard, what is a vine row and what is not a vine row. So the purpose of, from our point of view, we need to ground truth to train, validate and test our AI mapping solutions. And when you've got that, you can understand what's happening in terms of production. For example, what is the change in production area in Australia? And you can see like there are slight changes and slight growth in each area. So if you sum that information all up, you can see the temporal change. But also what you can do is you can actually understand what's happening spatially. So what we have here is a bit of information from the Barossa comparing the 2019 National Vineyard Scanned, so the 2019 vintage, with the 2020 vintage. And we have the 2019 vintage is in red and the 2020 vintage is in blue. And where they are both present, we have a purple highlight. But where you see the red, you can see those are actually vineyards that have been removed. And where you see the blue is those are new plantings or new vineyards. So while the overall number of hectares might look fairly stable, there's actually quite a lot of activity going as people are essentially replanting and renovating vineyards in the Barossa. Another project that we're looking at is how to automatically detect and map, provide early detections of diseases such as phylloxera. And it's really important for some of these authorities to, like AgVic, to really understand where new vineyards are being planted and where they're being removed for essentially biosecurity compliance measures. And if they can support earlier detection, it will reduce the amount of physical site surveys that they need to do. Another project sponsored again by PIRSA and Wine Australia and in collaboration with Adelaide University is essentially automating the assessment of damage to a vineyard post bushfire. So we can speed up that post bushfire survey process to understand what has happened. And finally, the one I'll go into a bit more detail is, again, thank you to Wine Australia and to Maxar and Barossa. We're looking at a project to essentially trial the ability to find gaps in vineyards caused by trunk disease such as UTPA. So we're talking about ground truthing and we're talking about physically going out into the field, and essentially what you need is you need skilled people. If you're going to assess, say, for a disease, you need skilled people to go through, and if you're going to do it on an individual vine basis, it's actually quite a manually intensive task. You need two people, one person to hold the GPS and make the measurements, use the tape measure, and the other person essentially is taking notes and recording it on a run sheet as they go through down one row, and they'll come back around the other row. And what you find, even with really skilled people, there's always some human error in ground truthing. And that's what I'm really going to talk about today is how do you deal with some of those challenges when you go out and physically survey? Because for our AI systems, we need really good data. It's only as good as the data that you put into it. So this is the bushfire project. So this is essentially the kind of flow that you get after someone surveyed a vineyard. You'll have a number of entries in, say, a spreadsheet, a CSV sheet, showing where they surveyed, what row it was. And here, in this case, in this bushfire case, this percentage is actually a score, really, between 1 to 4 on the level of severity of the fire damage. And then when you populate that into, say, a tool like QGIS, you can see the overall scoring of the damage assessment for that particular vineyard. Now, if we just zoom into one section here, you can see the points of where the person conducting the survey was. And essentially each point should represent a single vine. These are some of the things to consider, right? So this person doing the survey, they're walking through the middle of the row. And so then the GPS locations are offset from the vine row. And they should be identically, placed exactly, ideally they'd be on top of each vine, but they're not because of, it depends on where the actual GPS was placed, and there's also noise in the GPS measurement process. So you can see like there's like vines that are maybe potentially a bit beyond the row, potentially offset a row, and you can see the spacing changes. So these all create challenges. So one way to deal with that is to rasterize the data so it's essentially interpolated. So then you have some sort of map which you can then use to train your automated system. So that's one example. I've got another example here. So this is for the phylloxera early detection. And so now we've got our ground truth data, and what we can see here is we've got our points, and so it's come from a spreadsheet and taken a number of samples with different levels of severity, so different levels of impact from the disease. In this case, red is highly impacted by phylloxera, or very poor vigor in terms of the ground truth survey points. But what you can see is the number of samples actually varies along the rows. So we have these different row lengths that don't actually align up with the row data. And you can see it shifted compared, say, to the satellite image base map. So one process to do this, because essentially you don't know we still need to make use of that CSV file and to use it as best we can. So one way to do this is to draw a set of vine rows, or in our case, we use an automated AI algorithm to generate vine rows. And then we'll distribute the points along that vine row. And that will essentially give us a way of making use of this data and improving it for teaching our machine learning algorithm, for example, how to detect a particular disease. So those are some of the sort of the problems that we face and some of the challenges that need to be overcome. Very similar to what the other speakers have spoken about, ensuring that you get it right in terms of the survey point data. And then when you do get the survey point data, how do you deal with it? So the last example, this one I'll go into a bit more detail, is what can we do with this type of data? So one thing which we thought would be quite powerful is to, in the case of trunk disease, is to essentially map the amount of productive canopy that is available in the vineyard. So you could imagine at creation of the vineyard, you essentially have this conceptual vine row that goes from the first panel to the last panel, where there should be productive canopy along it. And so that's a total length in meters from the start of the row to the end of the row. Then essentially you have gaps in terms of number of meters. And these canopy gaps could be due to trunk disease, they could be due to something else. But then from the conceptual vine row, subtracted in meters, subtracted by the canopy gaps in meters, you essentially have the amount of productive canopy. And again, I just wanted to thank Brooke and Yolamba for supporting us. And then you can see you essentially want to number all the rows across the vineyard. And so how do we test this system, right? How do we test how well this works, say, if someone an expert was to measure it in the field? And so that's what I really wanted to talk about here. So this is what we get if we're talking about a ground truth survey. Again, we'll have a set of run sheets. There's more sheets associated with this, and you can see you might have row number, panel number, vine number, length of the gap in centimeters, and then a GPS location. There'll be some other data about which way the assessors were walking down the rows. And this is then translated into mapping software like QGIS. And you can see there's gaps here, but I just thought I'd like zoom in on a section here. Like, can you see my mouse clearly? And you can see that there's a little bit of an offset between where the person in the field said the gap was, and say you would see a gap on a satellite image. And you can see these differences need to be aligned so we can then evaluate how well an automated solution would work. So again, the next step is to there's a missing slide. The next step is to align this and then compare it to the automated solution. So here is essentially the ground truth once it's been aligned to the rows and then compared to the ground truth solution. And from that, we can then assess how well does our statistics on productivity from the automated solution to a manual solution compare. And in this case, we're talking about a double cordon block. So there's actually canopy on both the top and bottom. So there's some challenges with satellite image-based methods for detecting gap, because if you see like a gap on the bottom part of the canopy would be hidden from the top. So what kind of sort of performance are we getting? So one thing we're quite pleased about in terms was the vine row length, or the total conceptual vine row length. They seem to line up between the ground truthing and the automated. The row counts were the same, which is good. However, when you're out there in ground truthing, you know, when Frank was out there with Marnie, they can see lots and lots of small gaps on the top and the bottom. So they've picked up a lot more gaps than can be done with the automated satellite imagery solution. And that tends to, as well, like if you have two nearby small gaps, the automated solution will tend to merge those gaps into one. So the gap length varies a little bit between the ground truth and the automated, but the productivity loss is still fairly similar. But I think what's more important when you think about actioning is we look at, say, the top 5 rows that have had loss of productivity. And what we see is it's actually the same rows are coming up. So row 13, which is that unlucky row 13, is the same for both the ground truthing and the automated. Then 23, the automated solution missed row 1 as having a large number of gaps, but then it's fairly well aligned with some of the other row numbers. And so I guess, you know, we've been talking people through this, and I've got a little quote here from Hans, but I'll let Hans talk a bit later. But I guess the idea is this could be something that you do every year, and it's just a continual monitoring, so you can see and track where the tipping points are for diseases such as UTIPA. So it's essentially an ongoing survey of all the gaps in your vineyard and provides some sort of temporal history. So I'll leave it at that. It's a trial that's going on at the moment, and I'll pass back to Ollie for any questions, or onto the next slides.
And just in the interest of time, I'm going to throw straight to John Bryant, who is from Mammoth Geospatial, who's been helping us throughout this project as our kind of independent GIS expert. So John, if I can pull you in now, and Seth, if you can just pull down the screen.
Yeah.
And John's been looking at basically like so John's been rolling up his sleeves, looking at what are the options for us to actually, as an industry, like where could we publish like layers of mapping information that the industry feels comfortable to put in the commons in some level of openness. So he's going to give us just a very, very quick update on that, but then we're going to come back to John much more detail in August when he's finished all his work. But John, if you can just come in and give us a quick heads up. Thank you.
Sure, can do. So can you see my screen there, Ollie?
Perfect, thanks, John.
Yeah, okay, cool. So yeah, I'll just jump right into it. We've only got a couple minutes here. So many of us are dealing with block boundaries at some level, and it seems intuitive there are natural advantages to making this information more easily shared and more readily available where and when it's needed. So in the Collaboraculture project, we've previously looked at using shared data structures to make it easier to share data. And now we're going to look at some possible mechanisms for collaborating on building up data sets together. So essentially, we're taking a closer look at some ways we can build up a data set of vineyard block boundaries from the ground up. So we're sitting in a variety of situations in the broader community. Growers, surveyors, ag tech providers, and agencies, we all have different needs and capabilities. And as individuals, we bring our own attributes to the table. With the differences in the data formats and platforms we use, different skill sets and our own unique workflows, it's not easy to combine our efforts into something we can all benefit from. But fortunately, there are some lessons we can take from the software community, particularly the open source software community. So there are some well-established methods for combining the work of software developers who are distributed, work remotely, and work on different platforms. Git and Git-based hosting systems like GitHub and GitLab are version control frameworks with tooling for the difficult task of merging people's work together in a well-managed way. The landscape isn't as well developed for geospatial data, but there are a few open source projects coming available, such as, you can see the logos on the right there for GeoGig, CART, and Mergin projects. These are all open source community projects. So a collaborative workflow needs to accommodate users with different platforms, formats, and workflows, as we've said. So in this example diagram, we have input from users of open source and proprietary GIS platforms, QGIS and Esri, aided by the use of the Coordinates desktop app, as well as ag tech providers. So that's the user on the far top right there, providing their input through the open source geospatial version control project, CART. And so this model uses a centralized means of consolidating this input, which allows for some nuance when it comes to managing private data repositories and aggregating those repositories into a single point of truth. This type of model might require some level of governance to authorize somebody to make decisions about accepting and managing input and to maintain the system. So a totally different approach to governance might be to use an existing community-driven mapping project, OpenStreetMap. And so for those of you who don't already know OpenStreetMap, it's essentially the Wikipedia of maps. Anyone can sign up for an account and contribute to the map. Anyone can use the data for any purpose they like, as long as they credit OSM and its contributors. So there are millions of registered contributors to OSM, and it recently celebrated its 100 millionth change set. But get this, there are no centralized authorities making decisions about what's on the map. Rather, it's a large and engaged community that communicates openly to establish norms about what's acceptable and how things are structured. And so if you think this might result in complete chaos, just consider that Microsoft, Apple, Facebook, Uber, Mapbox, and Esri all use OpenStreetMap data to power their mapping platforms. So vineyards are already quite well represented in OpenStreetMap, with over 12,000 vineyard features in Australia and about 2,500 in New Zealand. But there are large gaps, and many of the boundaries don't necessarily represent exactly what the viticulture community would see as the truth. So OpenStreetMap is built on an ethos that those who are closest to the real world features being mapped are in the best position to add them to the map. So growers, surveyors, and agencies are probably the best situated to improve these OpenStreetMap boundaries with better data by adding it where it's missing and by improving features that already exist in OSM. So this could be done in a number of ways, using local knowledge and aerial photography, or possibly by using survey data, as we've been hearing about today. So for this to work, there would be a couple of key issues to work out for an approach like this to make sense. OpenStreetMap isn't a dumping ground where you can throw in any piece of information you like. There are community standards, and contributions that don't meet the standards may not persist. The first, it would make sense to be able to connect the data that's put into OpenStreetMap to external databases, perhaps by using a unique identifier of some sort, such as like a Collaboraculture ID or something like it. This ID could then be maintained elsewhere, alongside both public and private information about the blocks, and features on the map could be linked to any external database that uses that ID. Second, since anyone can edit OpenStreetMap, how do we maintain data integrity? So how do we know our carefully surveyed block boundary isn't going to be shifted by the next mapper that comes along? So some possible approaches to this issue include putting tags onto the features to indicate to future mappers that they're of high quality, working closely with the OpenStreetMap community to participate in establishing the schema by which features like this are mapped, and setting up automatic monitoring of the features that we're interested in so that we know when they change. So when people go in and change these features, we get alerted to it right away so that we can address data quality issues as they arise. And so the third issue here is OpenStreetMap data is subject to a license. It's highly permissive license, and it lets you do pretty much anything, well, it lets you do anything you want with the data, but there are obligations to credit users, and redistribution of the data may be subject to similar licensing. So this is something that would need to be sort of addressed to some degree before we could try that out. So in terms of benefits, by storing block boundaries in a massively open community project, we open the door to taking advantage of the huge ecosystem of tools that are already available. There are dozens of open source software tools and APIs connected to the OpenStreetMap database, and a large community of software developers and database administrators and community mappers already working in this space. So it becomes possible for ag tech providers to use existing open source libraries to fetch data from this open data source, so they can easily integrate the data into their own applications. With a high quality block boundaries data set in OpenStreetMap, we can be confident that everybody has access to good data and the systems that we all use will benefit. The OpenStreetMap project is well established with millions of users and extensive infrastructure, so there's no need to worry about maintaining any of our own. And last, with thousands of vineyards already mapped to some degree, we're already off to a great start. So that's it for me. Thank you. And yeah, back to you, Ollie.
Fantastic. Thank you so much, John. Yeah, and just by way of John's work, so yeah, our test vineyard in McLaren Vale, we're gonna, John's working away as a kind of a contributor to OpenStreetMaps to push that vineyard up there and work through kind of how to tag it and how to ensure that the rest of the community know that it's survey grade data going in there. So we'll work through that and share more in August. Just everybody in Zoom, I realize we're going over time slightly. We've just got one last presentation now, so hopefully you can stay on for Shay and Hans. So Shay and Hans first talked to us just before Christmas, and they were sharing some of their learnings from being in the mining industry and how you can pull in some of the things that they've learned geospatially in mining into viticulture. And Shay has done a lot of work in mining to use things like Power BI as a platform to help like smaller mining companies have access to some of the data and decision-making tools that used to be only able, like the BHPs of this world could have, and it's now kind of got democratized a lot. So with that, Shay, I'll pass over to you.
No worries. Thanks, Ollie. I'll just share my screen. And I'll try and be as quick as possible. Some of this stuff has been covered by some of the other presenters today. So yeah, just what Hans and I wanted to do was use some of the data from the Penley Estate vineyards to just prove that the logical data model can work and that we can do some useful representations of that data. So what we've done is, if we go back to, this was our model process that we presented back in whenever it was last year. So we have some inputs from various things. So these could be data that's collected from data providers. It's data that could be collected by a grower. It's data that comes from sensors, imagery, that sort of thing. We push everything through the logical data model in a SQL database, and then we create some outputs. So that was the conceptual part of it. And this is what we've actually done going through this process that we've been going through over the last month or so. So what we've done is we've taken the shape files from the block survey, I'll just go back, from the block survey that Hans had done. We've taken some data from Bitwise about bunch counts and canopy. We've taken some data that Hans has collected about growth stages and the layering of vines. We've put it through the logical data model, and we've created Power BI reports. We've created direct links to QGIS so that the data in QGIS is directly linked to the database. And we've also done QGIS with shape files as well, so you can export things. And the only other thing that's on here that I haven't shown is the CSV files that we've also created that can go out to various other, any other modelling software that you want to look at. Now, this is just a rehash of the steps that I've undertaken that was in the previous slide, and this is on the right is just the logical data model that we proposed last year, which it seems that a few people have taken on board, which is really good. Now, just going back to our little slide from last year with our vines and tractors, and we've sort of, the other speakers have covered this today, in that each vine has an area of influence, and we try and attach any data that we've got to a vine if it's vine level data. If it's block level data, it obviously goes against the block. If it's row level data, it goes against a row. And this is just a photo that Hans took in the vineyard yesterday, where he was out collecting some information about where he's layering vines that need to be replaced. And it just shows a good indication of how this area of influence along rows works around a vine. Now, what we did with the data from Bitwise was this was some bunch count data that we had. So what we've done to get around the problem of the GPS signal being in the mid row and not attached to either side of the row, so we don't really know which row it belongs to, we've had to manually select which row each line of data goes with. So using Hans's local knowledge, because he knows he went down every 15th row, so we know it's row 1, row 15, row 30, row 45. We've attributed the right data to that. And then because you get multiple frames per vine area of influence, we have to then attach a vine ID to each of these data points. And then from there, you can then compact the data down so that you end up with one data point per attribute per vine, which is what's shown in this bottom section. And this is the SQL Server data table that we've pushed this data into. And we've also made sure that we collect the attribute date. So the date that this data was collected can go on there. And this allows us to do some temporal mapping. So if you go and do the survey the same places through a season or season on season, you can then see how your yields are progressing as you go through time. Now, on the export sides of things, as I mentioned, we've got these things in QGIS that have, it's a normal sort of GIS type setup, and John made some nice style files to pretty this data up for us. We've also, as I mentioned earlier, we've got the direct links, so you don't actually have to go through the shape file. You can connect your GIS direct to the database, and as things change in the database, all you need to do is re-render the page and you get the updates with those. Now, the other thing is that not everyone knows how to use GIS, and so we want to be able to make this spatial connections a bit easier for people who aren't GIS users. So what we've done is we've built a whole lot of visualizations in Power BI. Now, Power BI isn't a GIS, but it does show you can display things on maps. Now, one of the limitations is that because it's not a full-on GIS, it doesn't show every point. So when I show you the Power BI demo in a minute, you'll see not everything's in a straight line. It's because what it's doing is it's taking a sample of the data to represent best the data that's being displayed. So you're not going to see every point on every visualization, but you'll get an idea of the patterns of the data from the data that's displayed. It allows us to visualize a lot of attributes easily, and we can put attributes against each other in different ways. And it's all fairly easy to put together. So it means that we don't have to, you don't have to cookie cutter a system for every different grower. Each grower can have tailored reports. And it's a really simple thing to learn to do the filtering and drill downs through it all. So I'll just flick over to showing some of that, and I'll come back to this summary later on. So if I just bring up my Power BI. So this is the Power BI reports that we've set up for Henley. And in the mapping that Hans has done on the vineyard there, we haven't got every single vine for every block. So there's still a few gaps, as you can see. And that's a work in progress that we'll get to when it happens. And so we've just made up some various different visualizations. So there's a way in here that you can just quickly get in and see all the attributes that are connected to your blocks. And then if we pick a block like the, let's say block 16, you can then click on that and it'll zoom you into that area. And all of the visualizations are all interactive. And so say you're interested in just seeing the blocks that are Shiraz, we can then zoom in just to the Shiraz blocks or the Cab Sav blocks. So it's all quite interactive. We can display the NDVI that we've collected for each of the vines. And so that's showing this. This is the colorblind color scale, but we can do whatever color scales are required. I won't go through every one of these because there's quite a few, but one of the interesting things was to compare the bunch count data. So we've got bunch count app here. So we've just done a few rows of bunch counts, and this was from the Bitwise data. But we can now fairly easily it's not very difficult for a grower to come in here and be able to then compare their bunch count data against the latest NDVI data that they have. And you can see there's a bit of a correlation between a lot of high yield vines here and where you've got good vigor in your vines. We've done the same for canopy height. And then we can get into some of the data that's been collected by the grower themselves. So turn that off. So Hans goes out once a week during his growing season and looks at this on a block by block level and assigns an EL number depending on the growth stage that we're at. So you can see all this data here as a table. We've also shown this as a chart. So you can see for each season how your growth stages are going. And these control lines that I've got on here are just showing the growth stages. And in this chart here, I've set it up so that we've got our 2020 season at the top and our 2021 season at the bottom. And you can sort of get an idea of how your different blocks are behaving year on year. And so you can fairly easily with these radio buttons just change that. So you're now looking at the 2019 season versus the 2020 season. So maybe this can give you some insights about how different seasons, weather patterns, or whatever you've done earlier on in the season is affecting your growth stages. And the last thing that I'll show you is just the layering map. So this is showing, I'll just have to turn this one off and I'll reassign it to block short. So this is where Hans has gone out on his quad bike and he's gone and collected a whole lot of points with his GPS, just by driving up and down the rows and stopping where he's got a vine that's been layered. And we can see that against the NDVI data as well. And maybe there's some correlations there, I'm not sure. But again, we're able to now see the correlation between where we've got layering of vines and where we have the NDVI counts.
And Shay, that will help just to, again, contextualize things. If you can bring up the percentage, basically, they're all the vines that have been grubbed. So they've had to go along and literally pull them out. So, and there is a point at which, like, I think it's 20%. If you get to a point where you're pulling out 20% of your vines in a block, that block is no longer typically viable. But it's really hard for big commercial growers to understand, when you're at scale, where you're up to. And suddenly, through this, it's like what Shay and Hans have been doing is making it possible to turn a lot of this mapping data and data that's captured by tractor-mounted cameras and putting it basically into a system that the managers of vineyards can now start to use to make proper decisions. So you can say, like, Hans is halfway towards having to rip that block out at the moment.
Yeah, that's all right. Thanks, Ollie, for jumping in there. Yeah, as I'm not a viticulturalist, I'm struggling with some of the subject matter expertise in all of this. Anyway, I guess that's all I really wanted to show you, and I'll just flick back to my PowerPoint again to just go through the summary. So the summary of all this is that having a single point of truth database, it serves as a place to have validated data. It also makes your data secure because this is being run on an Azure SQL Server database, so it gets backed up every 15 minutes, plus you can do long-term backups. So your data is always secure if it's in there. You're not going to lose your data by, I accidentally deleted that folder that contained that spreadsheet. Power BI allows you to get some easy insights into your data without very much training. And then we've also got the opportunities to go and send things on to GIS and other software platforms if that's what you use. Anyway, EarthSQL are pretty keen to work with some other progressive growers and expand on what we've done with Penley. So if anyone's interested in pursuing that, we'd be more than happy to speak with you. And I think that's all I've got to say at the moment. And I'm not sure Hans was able to make it today, so
no, thank you so much, Shay. And Hans, particularly, like, Hans is doing his Nuffield Scholarship at the moment, actually, like, specifically in this area. So yeah, as Shay said, if there are any wineries kind of out there, or wine producers really thinking about how they should structure their data going forwards, like, these guys have really been pushing the boundaries out there. So well worth hopefully engaging with them, and thank you for everything you've done to help us as well. So it's massively appreciated, incredibly generous. And it actually brings me on to just wrapping this session up. And thank you again for everybody for hanging on when we've just been running a wee bit late. Thank you. Just to wrap this up, so we're going to be doing another workshop in August. In that workshop, we really want to get into the nitty-gritty of things like the governance structure going forwards. So at the moment, it's mainly been John and ourselves who've been contributing to our GitHub page where we're publishing everything, but we want to open that up, and we're at the right point to now open that up to the rest of the community. So, you know, how can we get people like Matic and Ian in the UK who've been extending the data model? Like, we need to build a developer community that basically can act as maintainers and moderators and updaters of that code, so that we're all learning together. So we're going to send up a follow-up email next week and just offering that opportunity up to anybody in the community to hopefully be a part of Collabora culture going forwards as we start to kind of let it go more. So and as you can see, we're still working on this, but we're going to continue to publish more and more data up on the GitHub page so it's open. So we've started with just things like lists of varieties, but again, John just yesterday published all the GIS boundaries for Australia. So that's now published on the GitHub page. So is John's database model, and it might be that we do another instance of that, like Che has taken that into a SQL model, and we might publish that up as well, just again so that there's more and more instances for developers to be able to use. So if you can look out for the email from us for next week, it'd be great if you could hopefully be more of an active part over the coming months. And the August workshop, so we're going to be also touching on things like how do we actually publish, and under what copyright do we publish some of this data out there, and engaging with the whole industry to make sure they're comfortable with this. So I'm going to, you know, publish my vineyard on OpenStreetMaps. That is as open as you can possibly make it. It'll be out there forever, and because I'm comfortable with that. But like, where else do the rest of the industry sit on that continuum? So we want to get to the bottom of that, getting to the bottom of our governance structure. We're also going to work on GPS positioning. So we're doing some work about how accurate do we need to have vineyards for them to be still, those maps still useful. when we look at the level of accuracy that we have, you know, on a normal phone device, or maybe we're working with a device that has much more accuracy. So we're, you know, there's interplay between those two things. So do we need to be centimetre accurate across all of Australia like they are in Broadacre because they're having to plant at 2 centimetre accuracy, or do we have some bit more flexibility? So we're going to go and work to get to the bottom of that. And John is going to, again, come back to us with further worked out thoughts of, you know, what could the options be for the wine industry to go and publish some layers of data like openly for other developers to access. So we'll really try and round up on a lot of what we've been doing over the last few months in August. And thank you. There's some questions, and I know we've run out of time. There's some questions that have come through the chat, we'll follow up with everybody on those questions. I don't know if anybody in the audience has any burning questions, please ask them now. But if not, you're very welcome to come and see me afterwards, and I'll make sure I ask the right people those questions, because I'm really conscious that we've used a lot of your time this morning. And apologies again for everybody on Zoom for that slight hiccup. But we are now, hopefully the rest of that went really, really well. So, and thank you so much for everybody who spared their time, like in the middle of the morning in Europe, to come and join us. So thank you again.